Okay, so let's try to solve this problem called non-overlapping intervals. Given an array of intervals where intervals is start and end, so we have a start and end time, start and end time, start and end time. Return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So let's quickly understand this with the help of an example. Let's see. So these are, let's suppose, the intervals given to us: 0 3, 0 to 3, 1 to 2, 1 to 2, 1 to 2 again, 2 to 6, 2 to 6. Okay, 5 to 6, 5 to 6, 4 to 5, 4 to 5. Now, the most obvious thing that we can see here, 1 to 2 and 1 to 2 is overlap, is like the same interval. So definitely one of them needs to be removed. There's no optimization there. But let's look at this interval. We have one big interval, which is from 2 to 6, and we have two smaller intervals that is non-overlapping. Like the pair of intervals are non-overlapping. So it's like 5 to 6, we have 1, 4 to 5. So these two are non-overlapping, but because of this bigger envelope 2 to 6, we could have removed this 2 to 6, and then what we would have? We would have two non-overlapping sequences. They would be okay. So that's one option, to remove 2 6. Or we could have done something like we could have removed 4 5 and 5 6. 4 5 and 5 6. So that would have again made these three non-overlapping, because if we remove these two, this would be the only one present, or if we remove this, these two would be the only one present. So in this case, there's a condition for optimization, because we need to remove the minimum number of intervals. So the optimization would be that if I remove 2 6, I would be left with two more. That is the optimized result, because we need to remove the minimum number. All right. So that's clear. But that is local optimization. Let's think about in a larger scale. What would we have done? Okay. So the first intuition that I had was that if there's an envelope kind of an interval, like if I have multiple intervals between multiple intervals, and there's one bigger interval that's covering all of them, probably it's best to remove that envelope first. Okay, because that would lead to a minimum number of removals, right? So let's see here. If I have 1 2 and 1 2, definitely 1 2 and 1 2, we have to remove one of them. But if there was, let's suppose there was another interval. Let's suppose there was one from 0 to 1, 1 to 2. So in that case, what would have happened? Like we instead of removing 0 to 1 and 1 to 2, we could have just removed this envelope. In that case, those two would have become what? Non-overlapping. So for me, the best the minimum number of removals are in the case where we can remove the envelope, right? So all right, so let's start to see what the algorithm is. So this is a very famous problem. If we little like, and there are things, there are problems like this. So if you have done Russian doll and envelope, or any kind of problems where these intervals are given to us, right? So probably one of the most obvious intuitions is we have to sort them according to some of the parameters, maybe the start time, maybe the end time. So here I've sorted it according to end times. Okay, why? You just see this, because once we start sorting, I think the algorithm comes to us slowly. See, if I have sorted them according to n times, what would have happened? 1 2 1 2, they have 2 as their end time, so they have come first. Then we have 0 3 0 3 5, so 4 to 5, 2 to 6, 5 to 6. Okay, this is how we have sorted them according to the end times. You can see 2 2 3 5 6 6, so the end times are sorted. Now, in the case that the end times are similar, so let's say here we have a 6, here we have a 6, the end times are similar. In that case, should we sort according to the start times, or what should we do? Okay, you will see that it doesn't matter. We could just leave them as it is in any order if the end times happen to be same. Why? Okay, let us try to understand that with help of an example. Let's see, we try to sort it according to end times and the start times are similar, then what should be our strategy? Let's see. So it doesn't matter really. So, but let's see, why doesn't it matter? So my algorithm is, this is where I explain the algorithm. So please try to carefully listen. See, if I have 0 to 3, what would happen? Firstly, I have 1 to 2. So let's say 1 to 2. Next, I take the first one that I have in the list. I take that by default as my answer. So 1 to 2 is already a part of my answer. Next, I see that okay, I encounter another 1 to 2. That means what? This interval, this start time, it starts before my end time. So the start time of my second interval starts before my end time of my first one. So in that case, what does that signify? That it's definitely overlapping. So I will not consider the second one. I would not consider the second one. Great. Now I come to 03. So 03 is what? The start time 0. Now the second one has not been considered, right? So you have disregarded the second one. Now we have come to the third one, and the first one is already in our list of answer. So 03. Start time 0 is definitely lesser than the end time of our last added answer. So we will not consider 03. So we have not considered 1, 2, we will not consider 03. 4, 5. The start time of my current element is more than the end time of my last added answer. So 4, 5 is going to be added for sure. 2, 6. So 4, 5 I've added. 2, 6. You see the start time of my currently added element is lesser than the end time. So 2, 6 is definitely an interval that I cannot consider. So I have disregarded 2, 6. So 1, 2, 0, 3, 2, 6 disregarded. The last added was 4, 5. So 5, 6. The start time, that is 5, is more than equal to the end time. So I've told you that 4, 5, 5, 6 will be considered non-overlapping, right? So if the end time of the previous one, it coincides with the start time of the current one, it is non-overlapping, it's fine. So 4, 5 was the last added, 5, 6. So start time is what? It's more than equivalent to the end time of my previously added answer. So 5, 6 is going to be considered. So in this case, 2, 6 got disregarded, 0, 3 got disregarded, 1, 2 got disregarded. So we had 1, 2, 4, 5 and 5, 6 as the answer. And you can see if I have 1, 2, if I have 4, 5 and I have 5, 6, that would be actually my answer. That is the maximum number of intervals that can actually stay. So I have gotten rid of 0, 3, I have gotten rid of 2, 6 and 1, 2. All right. So that is the interval. So now let's see if we would have sorted them like 4, 5 and 5, 6. So see the end time 6 and 6, they are same. So I have once tried to sort them according to the start times. So if the start time is lesser, keep it at front. So it doesn't matter. See, if the start time was, if we would have kept 2, 6 at last, so the end times they coincide, and I have sorted them according to descending start time. This was ascending start time if the end times coincide. So with descending start time, it doesn't matter. See, if I've come to 4, 5 and 4 till 4, 5, the answer, the logic remains same, right? So I've added 4, 5. Now after that I encounter 5, 6. So I will definitely consider 5, 6. Why? Because 5, 6 is what? It's the start time is more than equivalent to the end time of 4, 5. So I'll consider this. But now when I come to 2, 6, you see the start time will definitely be lesser than so whenever I have an envelope, what happens? The start time is definitely lesser than what? Whatever start times, whatever end times I have seen in the like in the children or the interval this envelope covers. Obviously obviously the end times of all of these would be more than the start time of the envelope. So that is why 2, 6 will be the one to get cancelled. Okay, so it doesn't matter when the start or the end times coincide. You can just leave it as it is, because if this happens to be an to be an envelope, it will definitely have its start time to be lesser than the end times of the intervals it envelopes around. Okay, that's the thing. Let's look at another example just to make the algorithm drill deeper. Let's see, we have 1, 3, we have 1, 3, 2, 7, 5, 6, 9, 10 and 1, 10. Okay, so if I have one yeah, so see here also the ending times they are same. So here 9, 10 and 110 has the same ending time. So as I said, that doesn't matter. We can place the 110 before, 9, 10 after that, ascending start time, descending start time, doesn't matter. Let's see. In here what would happen? It would be the best would be if I would have gotten rid of 110, right? Instead of getting rid of 1, 3, 5, 6, 9, 10 to make it non-overlapping, we should get rid of the minimum number of intervals. So I'll get rid of 110 and 2, 7. So I'll be left with 1, 3, 5, 6 and 9, 10. Okay, hope that's clear. So now coming to the actual code. Here I have the actual code. The first thing that I've done is I've compared it according to their end time. So if the end time of, I sort them according to their end times, ascending end times. That's what I've done with the help of comparative function. Next, listen, we don't need to really add the entire interval in any list, right? So we don't need a space for that because I am only concerned with the start time and the end times. I'm not concerned with the entire interval, right? So what I've done is I've considered that by default, my first interval is a part of the answer. So by default, the first interval is a part of the answer. That means the end time that I'm currently looking at is 2, right? So this is the example that I'm working with. The first example in here, 1, 2, 2, 3, 3, 4, 1, 3. So uh, obviously I've sorted it according to their end times. See, 1, 2, 2, 3, 1, 3, 3, 4. So I've sorted them according to their end times. And now we are working on the logic. So by default, the first one is a part of my answer. So my ends at is 2. My ends at is at 2. Okay, so by default, because the first one is a part of the answer, I've considered the beginning to be answer 1. Next, on the second element, I start traversing. So I have I equals to 1, 2, intervals dot size, the entire thing. What do? I consider the currently the interval that I'm seeing. What is the start time of that interval? So the start time currently is 2. And if that start time is more than my previously added answer's end time, which is true, more than equal to, so 2 is greater than equal to this. Now this becomes my newly added or my last added answer. So 1, 2 was already there. I can now also consider 2, 3 as a part of my extended answer. So I've considered, so I've added now 2, 3. So addition means what? My new end time becomes 3. So that is why the end time has been changed to this newly added interval. So now my new end time is 3. Now I come to 1, 3. What happens? 1, 3. See the start time 1, 3. If you look at this, the start time, this is an envelope, right? So definitely the children come first and then I have the envelope. So 1, 2 has come first, 2, 3 has come, then I have 1, 3. Now definitely the start time would, so 1, 2, 2, 3 are part of the answer. So the start time of this current element is what? It's lesser than the end time of my previously added answer. So the start time would be lesser than, it won't be greater than equal to. That means I will not increment the answer and I would not change the newly added ends at. So nothing changes. I just skip this and then I come to 3, 4. Start time is more than equal to the last added end time, last added intervals end time. So definitely 3, 4 is a part of the answer and my new end time would be 4. That's what I've updated. And finally, so what does this answer hold? This answer holds the maximum number of elements that I had added in my answer. So what is the number of elements that were not added? That is basically the entire array size minus the intervals minus the size that got added. So that's what I've subtracted and returned the answer. Okay. So I hope that clears the question. So if there are any other queries, please let me know in the comments. Thank you.